Could a rock on Mars carry a sign of ancient life? Or is it simply chemistry frozen in stone? NASA's Perseverance rover has been exploring Jezero crater, a basin that once held a lake fed by ancient rivers. At the mouth of Neretva Vallis, the team identified the Bright Angel Formation, fine-grained mudstones, sediments that quietly settled in water and preserved chemical clues for billions of years. In 2024, Perseverance drilled a core here, a sample tied to an area nicknamed Sapphire Canyon. Within that core, scientists noticed unusual features, tiny, dark, circular patterns, nicknamed leopard spots. Some were only fractions of a millimeter wide. They appeared as repeating textures, embedded in Bright Angel mudstone. On Earth, patterns like these often form where water, minerals, and sometimes biology interact. That is why this discovery matters. To investigate, Perseverance used its robotic arm, Pixel, an X-ray fluorescence mapper, and Sherlock, a Raman and fluorescence spectrometer that detects minerals and organics.
The Perseverance rover starts with a design that's very similar to Curiosity. We've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures. We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
The results were striking. The rims of the spots were rich in iron and phosphorus, matching the mineral vivianite. The cores were rich in iron and sulfur, consistent with greigite. These minerals were locked in place for billions of years, waiting to be read. Here's the intrigue. On Earth, vivianite often forms in waterlogged, low-oxygen sediments, conditions influenced by organic matter. Greigite often appears in sulfidic settings, sometimes linked to microbial processes. Finding them together on Mars raises the possibility of similar chemistry, but science demands caution. Abiotic processes, purely chemical reactions, can also create these minerals. That is why NASA calls them potential biosignatures, clues, not proof. To know for sure, samples must come to Earth. That is the purpose of the Mars Sample Return mission.
As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
In laboratories, scientists can search for isotopic fingerprints, patterns in carbon, iron, or sulfur that reveal biology. They can image textures at nanometer scales and test whether the mineral structures align with microbial pathways. Until then, the Bright Angel core is the strongest hint yet, but not a conclusion. A reminder that Mars still holds secrets, locked in stone. So what do you think? Are these leopard spots genuine biosignatures or the artistry of Martian chemistry? Comment Team Life if you lean toward biology, or Team Chemistry if you believe it is non-biological.